Hi, this is Mr. Campbell. This is topic 0, day 2. How many numbers are at most 12? At most 12. So if we want to create a mathematical model using an inequality, at most 12 would be x is less than or equal to 10. Express it on the number line, then you draw a number line, of course, and it would look like that. And of course 0's here, 10 would be here. Since it's got an equal sign, it'd be a closed circle, and then less than would be all the numbers going this way. Then it says how many real numbers are greater than -2 and less than or equal to 5. Well, that would be -2 is less than x and less than or equal to 5. So it would be less than or equal to 5. It's a bounded interval. Expressed on a number line. Okay. So you have 0 here, -2 here, 5 here. So it would be an open circle at -2 and a closed circle at 5, and then you connect those two. It says how many real numbers are more than 3 or less than 0. Create a mathematical model. So this is the key word, or. Create it using an inequality. How many numbers are more than 3 or less than 0? So it'd be x is less than 0 or x is greater than 3. And the reason why I did the 0 first is on the number line, 0 is to the left of 3. So when we go to graph this baby, we have 0 here and 3 here. So x is less than 0, open circle, because there's no equal sign, which means 0 is not included in the solution. And greater than 3 would be here, open circle, and that would be going the other way, which is also not included. Another way to express our numbers is using interval notation. A pair of values that describes the minimum and maximum boundaries of the solution using brackets or parentheses and the infinity symbol, which looks like an 8 on it's taking a nap, the number 8 on its nap. Left endpoint using bracket, right endpoint including using right bracket, left endpoint not using left, parentheses, right endpoint not using right, parentheses, positive and negative infinity use parentheses. So let's talk about that. They want you to use interval notation. Make sure that, yeah, there's that. So let's go to the next page. Okay, so at most 10, if you remember, it was written like this. So if it's on the number line at less than 10, would be a closed circle. Now, on the number line, negative infinity is the smallest number something can ever be, and positive infinity is down here. So I work left to right, negative infinity and 10. And when you have a closed circle, that means brackets. That means 10 is part of the solution, so use brackets. Greater than -2 and less than or equal to 5. If you remember, our inequality looked like this. This is a bounded one. Notice the one above was not bounded because it has infinity. It keeps going on forever. So this one here would be -2 parentheses. And it's -2 because it doesn't have an equal sign. And 5. And 5 has brackets because it has an equal sign. It means 5 is part of the solution. The next one is more than 3 or less than 0. Okay, so more than 3 and less than 0. Three here, zeros here. Less than 0 would be like this, going this way, and then or more than 3 would be here, open circle, going the other way. So remember, you work left to right when you do interval notation. So negative infinities here, positive infinities here. So on the left is negative infinity because I have an arrow pointed that way. So it's going to be negative infinity. That's terrible writing. Press that there. Okay, so negative infinity. And whenever you deal with infinities, you always use parentheses, you never use brackets. So negative infinity to 0. Notice you have parentheses there because it doesn't have an equal sign. Or sometimes they'll use U. That means or as well. It means union. You have to add that or there, or that union symbol to connect them. Or more than 3. So more than 3 would be from 3 parentheses again to positive infinity because it's pointed towards positive infinity. At least 10. So that would be as an inequality, x is greater than or equal to 10. So then that would be 10 brackets to positive infinity. And then this one here, e, -4 to 0 would be -4. It's got endpoints, parentheses, to 0. Infinities never have brackets on them. They have parentheses. Now let's take a look what we learned about solving absolute value inequalities and apply that to solving absolute value and inequalities. So we've learned in yesterday's lesson how to do equations. Today we're going to do inequalities. They are the same. They are solved the same, I should say. Let me erase this here. When you solve these inequalities, they are going to be intervals. They are intervals instead of points. They are intervals instead of points. Intervals. So, for example, this one here is less than or equal to, so this one here, x is less than or equal to c. Your solutions are going to be x is greater than or equal to -c. And whenever you see less than, that means and. And, it's an and problem. X is less than or equal to c. Here we got greater than, so that's going to be x is less than or equal to -c, and this should be or, excuse me, or. This is an or problem because it's greater than. And x is greater than or equal to +c. So when it's less than, it's an and, which means there's going to be endpoints. And greater than means they're going to be infinity symbols. Okay? So this first one here we want to write, so like, as I said, both conditions must be satisfied. Here, only one condition needs to be satisfied. It can be both, but not required. So only one condition needs to be satisfied. It can be both or not, but it's not required. Okay, sorry about that. Getting towards the end of the day, I'm getting tired. All right, this is a greater than problem, which means this is going to be an or. So first inequality will be 4x plus 5. Our reverse inequality is less than negative 13. The second inequality will be 4x plus 5 is greater than 13. So the second equation, just copy it down and get rid of the absolute values. The left equations, you negate the 13 and then reverse the inequality. Okay, so I'm going to solve this thing here. So I'm going to subtract 5 from both sides. And divide by 4, so I get x is less than negative 9 halves. When I write that, negative 18 fourths is negative 9 halves. You could also write it as negative 4.5, same thing. This in here, I'm going to subtract 5, so I get 4x is greater than 8. Divide by 4, I get x is greater than 2. And remember, this was an OR problem. An OR problem. This greater than determines it's an OR. So when we go to graph it, we go, there's 2, and negative 4.5 is about right here. So x is less than negative 4.4, so it's going to be an open circle going this way. And then the other one is x is greater than 2, so it's going to be an open circle going this way. So then when we write our interval notation, it would be negative infinity to 4.5, negative 4.5, right? Or 2 to positive infinity. So you work left to right. Negative infinity is down here on this number line, and positive infinity is here. So you have negative infinity to negative 4.5. Or you could write negative 9 halves. And then this one here is 2 is greater than 0, so or 2 is comma, 2 commas positive infinity. Positive infinity will always be to the right, and negative infinity will always be to the left. Just checking something here. Making sure I have all these done. Okay, example 6. First thing you always have to do is always get this absolute value by itself. Okay, so the first thing I'm going to do is divide both sides by 2. So those cancel and leaves me the absolute value of 1/2 x minus 10 is less than or equal to 4. Then now I write my two inequalities. My first one is 1/2 x minus 10. Reverse the inequality and then negate the number. And then the second one is 1/2. The second one, you just copy it off the paper we wrote it on. So there's your two inequalities. And since this was a less than problem, this is an and. An and problem, which means intersect. What do they share in common? So on this one here, I'm going to add 10. Now you have 1/2 x is greater than or equal to 6, so you got to divide by 1/2, which is the same thing as multiplying both sides by the reciprocal. So we get x is greater than or equal to 12. And this one here, I'm going to add 10 to both sides. And then divide by 1/2, which is the same thing as multiplying both sides by 2. So I get x is less than or equal to 28. So when I graph this baby, 0, 12 is here, and 28 is here. X is greater than or equal to 12, and x is less than or equal to 28. So you're going to have a closed circle at 12 and a closed circle at 28. You're going to connect them. And that's what those ands normally look like. Not all the time, but 90% of the time they're going to be endpoints. So then I'll have, if I wrote it in interval notation, it would be brackets 12, brackets 28. And the reason why you use brackets is because you have closed circles. Okay? Again, before you do anything with these absolute value inequalities, or the first homework 0-1, topic 0-1, day 1, you still always get this thing, get rid of everything on the outside before you write your two inequalities. So I'm going to subtract 3 from both sides. So that gives me, getting out of summertime here. There we go. Subtract 3 from both sides. So that gives me negative 2x plus 3. Absolute value is less than or equal to 5. Since this is less than, this is an and problem. So my first inequality will be this. Get rid of the absolute values, reverse the inequality, and negate the number. And 2x plus 3, just write it down and then get rid of the absolute value symbols. Absolute value means distance from 0. So subtract 3. So I get negative 2x is greater than negative 8 divided by negative 2. If you remember from Algebra 1, whenever you have an inequality, you divide by negative or multiply both sides by negative. Divide or multiply if the reverse inequality. So we have to rewrite this as x is less than positive 4. That's the reverse inequality. And we do the next one. I'm going to subtract 3. So I get negative 2x is less than 2, and then to divide by negative 2. So it gives me x is greater than negative 1. Because I'm reversing inequality, and 2 divided by negative 2 is negative 1. So let's graph this baby. So we have x is greater than negative 1. Man, still in summertime. Negative 1. And less than 4. So you're going to have open circle going this way and an open circle going back the other way. So where do they intersect? What do they share in common would be that line between them. And then an interval notation would be from left to right, negative 1. It's parentheses because it doesn't have a equal sign or closed circle. 2, 4 is also going to be parentheses because there's not a closed circle. So that's the lesson, day 2, 0, day 2.